This video is about theoretical yield. Yield literally means the amount of product that you make. And what we mean by theoretical yield is nothing to do with actually measuring the amount of product that you make. It's the step that you would do before. It's using a calculation So it's doing the maths before you even do a reaction to see how much you make. And this is really important for industry because they need to know how much product they're going to make with certain masses of reactants that they put in. Otherwise they'll just waste money. They'll make either too much product or they'll make not enough product. So for industry it's really important. So I've got two examples here of theoretical yield calculations similar to ones that you might face in the exam, and they're often worth several marks because there's quite a few steps to the questions. This first one here, we've got calcium carbonate being broken down into calcium oxide and carbon dioxide, and the question is, if 50 grams of calcium carbonate was heated, how much calcium oxide would be made? So if 50 grams of calcium carbonate was heated, how much calcium oxide would be made? And with these theoretical yield calculations, we often ignore whatever else is in the equation, okay, because it'll only ask about one product normally. So don't worry if you're completely ignoring the carbon dioxide here in this question, because it doesn't mention that anywhere here. So the first thing that we need to do is check that our equation is balanced. So number one thing that we need to do is check if the equation is balanced before we do anything else. So we look here, we've got one calcium and one calcium this side, one carbon this side, 3 oxygens on the left, and 1, 2, 3 oxygens on the right. So this is balanced and we don't need to do anything else. So when we're calculating theoretical yield, first of all we need to calculate the MR of calcium carbonate and the MR of calcium oxide. So if you remember back, we need to know from our periodic table the relative atomic masses of calcium, carbon and oxygen to be able to work out the relative formula masses of these two compounds. So just from my periodic table, by looking at the relative atomic mass, I know that calcium is 40, carbon is 12, and oxygen is 16. So sometimes they give them to you in the question, other times you'll have to look at the periodic table yourself for these. So after we've checked to see if our equation is balanced, I'll put this up here so it's out of the way. The next thing we need to do is calculate the relative formula mass of each one. So step 2, calculate the relative formula mass, remember that's shortened to MR, of the compounds in the question. So this one is of CaCO3 and CaO. So first of all, CaCO3, the MR here would be 40 for Ca plus 12 for carbon, and there's 3 oxygens, so we need to do 3 times 16. So we'll need our calculator to work this out, and we do 40 plus 12 plus 3 times 16, and we see that calcium carbonate has a relative formula mass of 100. And then I always try and do this in columns just to keep everything separate, we need to calculate the relative formula mass of calcium oxide. So we've got Ca, which is 40, plus oxygen, which is 16. So the relative formula mass of calcium oxide is 56. So when we've got these two numbers here, we can say to ourselves 100 grams of calcium carbonate will make 56 grams of calcium oxide. So I'll write this down here. 100 grams of calcium carbonate will make 56 grams of calcium oxide. Okay, we know that from the relative atomic masses. So simple adding up gets us to this stage. 100 grams of calcium carbonate will make 56 grams of calcium oxide. Now we've been asked what 50 grams of calcium carbonate would make. Okay, so some of you might already be jumping to that step straight away and think, well, if I've got half of the amount of calcium carbonate, I will make half of the amount of calcium oxide. And you'd be right, but let's take it through the steps anyway, just so that we can make it easy for any situation we've got. If this is a little bit more difficult, like 56 grams or 58 grams, then we need to do this following step. So now we know 100 grams of calcium carbonate makes 56 grams. Our third step would be to work out what 1 gram of calcium carbonate would make. And to do this, we have to divide 100 by itself to get 1 gram. So if we had, like we had before, 100 grams of calcium carbonate and 56 grams of CaO, calcium oxide, we divide both sides by 100, and that would mean 1 gram of calcium carbonate would make 0.56 grams of calcium oxide. Which brings us to our final step, which would be to multiply both sides by 50 so that this read 50 grams of calcium carbonate over this side. So our final step would be to multiply by 50 so that we get 50 grams, because that's what the question has asked us. So on this side, 1 times 50 is 50. So 50 grams of calcium carbonate would make, on our calculator, 0.56 times by 50, which is 28 grams of calcium oxide. So in answer to our question, 50 grams of calcium carbonate was heated, how much calcium oxide would be made? And the answer is 28 grams of calcium oxide. So in the next example, we've got iron plus oxygen makes iron oxide, and the question is, how much iron would you need to produce 325 grams of iron oxide? Now, if you remember, our first step that we need to do for any of these is check to see if the equation is balanced. So here we've got 1 iron on the left, 2 irons on the right, so we can see straight away it's not balanced, and 2 oxygens and 3 oxygens. So we need to balance this equation first of all as our first step in these theoretical yield calculations. So to balance this equation, we are first going to put a 2 in front of the iron oxide here and a 3 in front of the oxygens. That first of all balances out the oxygens, so we've got 6 on this side and 2 times 3, which is 6 on this side. But now, because we have got 4 ions, we need to put number 4 here to balance out this equation. So 4Fe plus 3O2 makes 2 Fe2O3. So our question is, how much iron would you need to produce 325 grams of iron oxide? So how much iron to produce 325 grams of iron oxide? And in this case we're going to be ignoring the oxygen in this equation. So our second step, as we said before in this question, was to calculate the MRs, the relative formula masses. Calculate the MR of 4Fe and 2Fe2O3. So for the 4Fe, first of all, we look on our periodic table, and iron has a relative atomic mass of 56, so it would be 4, so iron is 56, so it would be 4 times 56 for the relative formula mass of 4Fe, which is 4 times 56, 224. For iron oxide, we've got Fe equals 56 and oxygen is 16. So we need to do 2 lots of Fe2O3. So we need to do 2 times 56 times 2 plus 2 times 16 times 3. So 56 times 2 times 2 is 224, and then 2 times 16 times 3 is 96, and if you add those together you get the relative formula mass of 320. So now, using this information, we can write down that 224 grams of iron would make, should write that as 4Fe really, would make 320 grams of iron oxide. Okay, just from our relative formula masses we can now just put grams on the end and that would be true. But our question says, how much iron would you need to produce 325 grams of iron oxide? So we do our third stage and work out how much you would need to make 1 gram of iron oxide. So in step 3, we would work out how much Fe would be needed to make, 4Fe should put, to make 1 gram of iron oxide. So we divide both masses by 320, so we've got 224 grams from here of iron and 320 grams of iron oxide, and we divide both sides by 320 this time. It's the opposite way round before because the question is the opposite way round, and from that calculation we know that 0.7 grams of iron would make 1 gram of 2Fe2O3 iron oxide. So the final step is to times both sides by 325 because we need to know how much iron you would need to make 325 grams of iron oxide. So times both sides by 325 gives you 0.7 times 325, which is 227.5, and 1 times 325, which is 325. So 227.5 grams of iron would make 325 grams of iron oxide. So in answer to our question here, how much iron would you need to produce 325 grams of iron oxide? The answer is 227.5 grams. So here's some questions for you to have a go at. Remember, you need to find out whether these equations are balanced first before you start the calculations. Okay, so for the first question, sodium plus hydrochloric acid makes sodium chloride plus hydrogen. How much sodium would you need to react with hydrochloric acid to produce 10 grams of hydrogen? So first of all, we need to see whether it's balanced. So here we've got 1 Na and 1 Na. On the left we've got 1 Cl and 1 Cl. On the left we've got 1 hydrogen, but on the right we've got 2 hydrogens. So straight away we see it's not balanced. So to balance it, if we put a 2 in front of HCl, that gives us 2 H's, but now 2 chlorines. So we need to put a 2 in front of sodium chloride. So that gives us 2 sodiums and 2 chlorines. And now we have to put a 2 in front of sodium. So now on the left hand side we've got 2 sodium, 2 hydrogen, 2 chlorine, and on the right hand side 2 sodium, 2 chlorine and 2 hydrogen, so we're all balanced now. So how much sodium would you need to react with hydrochloric acid to produce 10 grams of hydrogen? So we are looking at how much sodium is needed to produce 10 grams of hydrogen. So in this case we can ignore hydrochloric acid and we can ignore sodium chloride. So the relative formula mass then for sodium, so we've got 2 times sodium, the relative atomic mass is 23, and hydrogen, the relative atomic mass is 1. So we've got 2 lots of sodium, so 2 times 23, which is 46, and on this side 2 times 1, which is 2. So 46 grams of sodium would make 2 grams of hydrogen. I always would recommend to write this step down just because it helps you clarify your workings out. So we need to work out how much sodium will produce 10 grams of hydrogen. So we need to change this number to 10. So to do this we divide both sides by 2. So that this will make 1 gram of hydrogen, and this will make 23 grams of sodium. And then we can times both sides by 10 so that we can work out 10 grams, because that's what our questions asked us up here. So times both by 10, and that would mean that to get 10 grams of hydrogen we would need 230 grams of sodium. For the next question, we've got magnesium carbonate plus sulfuric acid makes magnesium sulfate plus water plus carbon dioxide. The question is, what is the minimum amount of sulfuric acid you would need to produce 125 grams of magnesium sulfate? So don't be thrown off by the fact that it says minimum amount. It just means what amount of sulfuric acid would you need to produce 125 grams of magnesium sulfate. So we're looking at how much acid we need to make 125 grams of magnesium sulfate. So these are the two compounds we're interested in. We're not interested in anything else in this reaction. So the first thing that we need to do is make sure that this equation is balanced. So we've got 1 Mg on the left, 1 Mg on the right, 1 carbon on the left, 1 carbon on the right, 7 oxygens on the left, 4, 5, 6, 7 oxygens on the right, 2 hydrogens on the left, 2 hydrogens on the right, and 1 sulfur on the left and 1 sulfur on the right. So it's already balanced, and we can go straight into our theoretical yield calculation. So we need to work out the relative formula masses of sulfuric acid and magnesium sulfate. So we look on our periodic table. The relative atomic mass of hydrogen is 1. Relative atomic mass of sulfur is 32. Oxygen is 16. Magnesium is 24. And those are all the elements we need to calculate the relative formula masses. So for the formula mass of H2SO4, you should have done 2 times 1 added to 32 added to 4 times 16. And on the calculator, that's 2 times 1 plus 32 plus 4 times 16, which equals 98. So the relative formula mass of H2SO4 is 98. And on the other side, MgSO4 we've got 24 for Mg plus 32 for sulfur plus 4 times 16. So on our calculator, 24 plus 32 plus 4 times 16 is 120. So we write out our sentence to say that 98 grams of H2SO4 would make 120 grams of MgSO4. Then we look back at our question. It says, what is the minimum amount of sulfuric acid you would need to produce 125 grams of magnesium sulfate? So it's the magnesium sulfate we need to get down to 1 gram. So we divide both sides by 120. So 98 divided by 120 is 0.82 rounded up. So 0.82 grams of H2SO4 makes 1 gram of magnesium sulfate, but we need to produce 125 grams, so if we times both sides by 125, so 0.82 times by 125 means that 102 grams of H2SO4 would make 125 grams of magnesium sulfate. So our answer would be 102 grams. Just to bear in mind also, if you'd left the 0.816 as it was in the calculator and then times it by 125, you would have got my answer of 102 grams. But if you'd taken this answer and multiplied it by 125, you might have got the answer of 102.5 grams. So if you got that answer, don't panic at all. It's just a case of a rounding error to give the difference of 0.5 between the answers. So just bear that in mind in the exam. They very rarely penalise you for such a rounding error like this. But just one to bear in mind, if you do use the figure that's on your calculator, you might end up with a slightly different answer to somebody else who might have rounded it up and then put their numbers in the calculator.